Hello, grade 12. In today's lesson, we're going to be looking at trigonometry proving identities. And without any further ado, let's just get right down to the lesson. So, okay, we have here, it says prove the following. And then we know the deal with this one is that we want to prove the left-hand side. We want to prove that the left-hand side is equal to the right-hand side. So as we can see here, we are given a, and then it's sine 2x over cos 2x plus sine squared x. And then the right-hand side is 2 tan x. So we're going to start by writing left-hand side to indicate that we are solving from the left-hand side. Now, how do we go about this one? If you are looking at this one, you can see that this is a double angle. Then from your formula sheet, we know that this one, we can break it down to be 2 sine x cos x right away, right? And then we have this one cos 2x, but then looking at cos 2x, we know that cos 2x can break into 3 different ways. We have cos squared x minus sine squared x, and then we have 2 cos squared x minus 1, and also 1 minus 2 sine squared x. But looking at our equation, we can see that we have sine x here, and then it will probably be best that we break this one to sine, because we can see that there's also sine in here. So let's break it down to sine. We have 1 minus 2 sine squared x plus sine squared x. So having that in the numerator, we have 2 sine x and then cos x. And then below, that's negative 2 sine squared x plus sine squared x. This will give us 1 minus sine squared x. At this point, we can see that we have a grade 11 identity, which goes 1 minus sine squared x is equals to cos squared x. So we can just change all this to that. Right, so now we have 2 sine x. Remember, the goal is to get to tan. So we know that tan x is equals to sine x over cos x. So the goal is that we have sine here in the numerator, and we have cos in the denominator. So we have 2 sine x and then cos x over, if we change this one, it's cos squared x, which we know this one can also be written as 2 sine x, and then cos x, then cos squared x, that is the same as me having cos x. Now you can see that the cos x and cos x will cancel out, and then we are left with this 2 sine x cos x. But remember, tan x, sine x over cos x is equal to tan x here. Right, so that means our solution is 2 tan x. At this point, we can now say that the left-hand side is equals to the right-hand side, because we have proven all this to be equal to that. Okay, let's look at B. So for B, let's solve all this, the left-hand side. Again, we are solving from the left-hand side. We have sine theta 1 minus cos theta. Then at this point, 1 minus cos theta minus cos theta over sine theta, right? So this is the left-hand side. Now at this point, we can see that the denominators are not the same, so we can make our LCM by just multiplying the denominators there. So that's 1 minus cos theta and then sine theta. Now we understand that if we take all of this divided by the denominator here, this and that will cancel and we'll only be left with sine theta. So sine theta multiplied by that sine theta, there we have sine squared theta. And then what about here? If we take all of this divided by sine theta, we understand that sine theta will divide out sine theta, and then we'll be left with this 1 minus cos theta to multiply with the numerator there. So we have cos theta and then multiplying by that. So that's how we have it. And then continuing to solve here, we have sine squared theta minus. So if we FOIL in here, we have if we visit here, meant to say, then that's cos theta times 1, it's negative cos theta times negative cos theta. That gives us positive cos squared theta. But if you can remember grade 11 identities, if we take this one and that one, that gives us 1, right? So okay, let's just continue, put that one in like that. So remember, sine squared theta and cos squared theta will give us 1 when we add them together, coming from a grade 11 identity that goes sine squared theta plus cos squared theta is equal to 1. Then we have 1 minus cos theta over, in bracket 1 minus cos theta, and then we have that sine theta. Now at this point we can see that 1 minus cos theta is similar to this 1 minus cos theta in the denominator. So what will happen? The two can divide out, and then in the numerator will only be left with 1, since 1 minus cos theta divided by 1 minus cos theta has to give us 1, and then we are left with this sine theta in the denominator. So that becomes your solution, and then as you can see, it is equal to this right hand side. So we then say, therefore left hand side is equals to right hand side. Okay, let's check C. So in C we have sine 2x over sine x minus cos 2x over cos x, and then we must prove this left hand side. We must prove from the left hand side. Now at this point we can also see that the denominators are different, so we can just make these two to be our lowest common multiples. Then that's how we have it. So if we take all of this divided by that, this and that will divide out, and then we'll be left with sine 2x to multiply with this cos x that will be left there. And then again here, if we take this one, all of this divided by this and this will divide out, and then we'll be left with minus cos 2x, and then it will multiply with this sine x that's left here. Now if you can just observe carefully here, you can see that there is a particular compound angle that we have here, right? So if you can look at your compound angles in your formula sheet, you know that if you have this compound angle which goes alpha minus beta, that's sine alpha cos beta minus cos alpha sine beta, right? And this is exactly what you have here. So we must reduce all this to this, right? So that means we have sine 2x. So this becomes our more like our angle alpha, and this is our angle theta. So we have that minus x over sine x cos x. Now what is 2x minus x? That will give us sine x, and then over sine x cos x. Now we can see that sine x and sine x can divide out. Therefore left hand side is equal to right hand side. Okay, now let's look at D. So again in D we must prove that the left hand side is equal to the right hand side. So proving from the left hand side, we have 1 minus this, so cos 2x. Now let's be strategic about this. Looking at here, we have sine x, so we know it will be best to change this one to sine. So we have 1 and then we have 1 minus 2 sine squared x minus sine x, then over sine 2x. So this one is a double angle, we can change it to 2 sine x cos x minus cos x. So we are trying to to arrive to this answer here. So solving here, we have negative times this positive 1. So we're going to have 1 minus 1 and then negative and then negative. That's plus. So 2 sine squared x minus sine x, and then over 2 sine x cos x minus cos x, because I haven't seen the relationship there. Let me write it like that. Then this is 1 minus 1, that's 0. Then I have 2 sine squared x minus sine squared x. Now at this point, with what I'm left with here, so this and this will cancel. With what I'm left with here, I can see that I can factor out sine x. So let's go. I have sine x, and then this will be 2 sine x minus 1. And then what about what I have below here? I can see that I have a common factor of cos x, so I can factor out cos x, and then this here I'll be left with 2 sine x, and then factoring out this cos x, I'll only be left with 1 there. So now I can see what's going on. This 2 sine x minus 1 is similar to this 2 sine x minus 1. So what will they do? They will divide out. So I'm left with sine x over cos x, which according to our grade 11 identity, we know that's equal to tan x. Then in that way, we have proven that the left hand side is equal to the right hand side. Okay, let's look at E. So E, we are given all of this sine 180 degrees plus x, which we know this indicates the third quadrant. So how is sine in the third quadrant? We say sine in the third quadrant is negative, so we have negative sine x. And then what about this? This is x minus 360, which is indicating a negative angle. Now, what is the negative angle of tan? We know that negative angle of tan is negative, but then if you can check this, tan is in the fourth quadrant. So if we can just rearrange that one, this indicates that tan is negative angle here, then 360 minus x, right? So, and then we have this cos 38 here. So let's write cos 38, because we haven't seen what's the relationship with that one. And then tan in the fourth quadrant. How is tan in the fourth quadrant? It is negative, so we have the negative tan x. And then what about here? We have sine x minus 180 degrees, which again, this indicates a negative angle. So let's arrange it. We have sine negative 180 degrees minus x. Then cos 240 degrees, we can break that down to cos. Remember, with this one, it's in the third quadrant, but then you want to avoid 270 minus theta. So rather use 180 plus theta, which will now be written as 180 plus 60 degrees, which is a special angle. And then what do we have here? We have tan 225. So tan 225, I believe that's 180 plus 45. And then we have this sine 488, which we can see 488 is bigger than 360. So we have to say 488 minus 360. That will give us that should give us 128 if you punch it. So that's sine 128 degrees, right? Then here we have negative sine x, and then tan of a negative angle is negative, but tan is in the fourth quadrant where it is also negative. So that negative and negative will give us a positive. So we have tan x, and then cos 38. Let's just write this cos 38 and then see where we get with that one. Then we have this negative tan x here. Now, what is sine of a negative angle? It's negative, and then sine is positive in the second quadrant. So negative and positive will give us that negative. So negative sine x. Then cos in the third quadrant is what? Is negative, so we have negative cos 60 degrees. And then what about this one? Tan in the third quadrant is positive, so we have positive tan 45. Then we must do something with this 128, so we can write it in terms of the reduction formulae. This is 180 because it's in the second quadrant. 180 degrees minus 52 degrees, right? Then let's continue. We have negative sine x and then tan x. Now, having seen that we have 52 here, we can also see that this 38 can also be written in reduction formulae in the first quadrant to be 90 minus 52. Now we have a relationship of that angle right now. So we have 52 and 52, which we know for non-special, right? For non-special angles, we expect them to cancel out. Then here we have a negative and a negative, which will give us a positive, but multiplied by this negative, it's a negative. So we have tan x and then sine x and cos 60 degrees, then the tan 45 degrees. And now this is in the second quadrant, it's sine. So we know sine in the second quadrant is positive, so we have sine 52 degrees. Then here, what do we have? We have negative sine x and then tan x. This will now be, remember, cos 90 minus is a cofunction, so this will now be sine 52 degrees, which now we can see that it will cancel out with that one. So we have negative tan x and then sine x. Now we can just write these ones because we know the special angles. What is cos 60? That's half. And then what is tan 45? That's 1. And then this sine 45 here, let's write this sine 45 degrees, sine 52 degrees. So this sine 52 degrees will cancel out with this sine 52 degrees. And then we have tan x cancelling out with this tan x. Negative and negative will be a positive. Then sine x, sine x. So we are only left with 1 in the numerator. Remember, if everything divides out, then we are only left with 1. Then what is half times 1? That's half. So 1 divided by half, that should give you 2. So in other words, here we were supposed to have positive 2 instead of negative 2. Okay, now let's look at the last one. We have this, the left-hand side, so we are trying to prove that it is equal to the right-hand side. So this is cos squared 90 plus theta, and then over cos negative theta plus sine 90 degrees minus theta, and then cos theta, right? Then, okay, what we see here is this is the second quadrant, and then we know that cos in the second quadrant is negative, but then 90 plus, this indicates that it will change to its cofunction. So we know that cos is negative in the second quadrant. Therefore, when it changes to its cofunction needs to be negative. But remember, now we have it squared like that. So that's negative sine theta, but squared. Then what is cos of a negative angle? We know cos of a negative angle is always positive. So substitute any angle here and make it negative. You will see that cos will come out as a positive. Then also here we are faced with another cofunction, sine 90 minus theta. We know this one should change to cos theta because it's in the first quadrant. All trig ratios are positive there. Then times cos theta. Now at this point above here we have sine squared theta, and then this one we can see that we have a common factor of cos theta, so we can just factor it out. Cos theta then will be left with 1 here, and then plus cos theta. So we just factoring out 1 cos theta, we are only left with 1. But remember, this one, according to our grade 11, According to our grade 11 trig identities, this can also be written as 1 minus cos squared theta, and then over cos theta 1 plus cos theta. Now we know this is a difference of two squares, so we can write it out as this. Remember, we are trying to look for that expressions that will cancel out here. So knowing that this is difference of two squares, we can write it as 1 minus cos theta and 1 plus cos theta, right? So still it won't give you any middle term because that's a plus and minus. Then below we have cos theta here, and then 1 plus cos theta. Now at this point we can see that we now have a common expression in the denominator and numerator. So what will happen? They will divide out. So they will divide out, and then we'll be left with 1 minus cos theta over this cos theta. Now at this point we know that we can express everything here to the denominator of cos theta. So we have 1 over cos theta minus cos theta over cos theta. Now at this point we have this will be equal to 1 over cos theta, but then cos theta over cos theta, that's 1. So that's our solution. Therefore the left hand side is equal to the right hand side. Awesome.